Good morning, everyone. So, well, it's 11. We are going to start. Maybe I'll wait a few seconds because some attendees are joining, but all our speakers are here. So, I'll start with the logistics information. This will give time to for more attendees to join. So, good morning, everyone. Welcome to this 19th ETP4HPC webinar. I am Pascal. I'm ETP4HPC's communication manager, and my colleague Maike is also here to help run the show. She's shy. She switched off her camera, but she's here. And for those of you who are not familiar with ETP4HPC, we are a non-profit association that promotes European research and innovation in high-performance computing in HPC. So we are a private member of the EuroHPC JU, which is the organization in the European Commission that addresses HPC. And our role is an advisory role. We propose research priorities for Europe in the area of HPC, of course. So now let's get to today's subject. First, practical information. So this webinar is recorded and you will receive the link to the recording tomorrow. This webinar is in listen-only mode, but you can use the GoToWebinar control panel that's illustrated here to ask questions. There is a question panel. And you can also download handouts. There is a handout section. If you look at it, you'll see that the slides for today's webinar, they are here in the handouts. You can download them. And I have also put the flyer of FF4EuroHPC. The FF4EuroHPC flyer is here in the handouts. So you can submit questions at any time during the presentation, but we will answer them at the end during the Q&A session. And I will share your questions in the chat so everybody can see them, but we will answer them at the end. Okay? So let's get to today's subject. So we have invited FF4EuroHPC to present two of their use cases, two of their success stories. And they are very exciting use cases, you will see. At least I find them really exciting, really interesting. But first of all, we would like to know more about FF4EuroHPC. So Tina is their dissemination lead. Tina, can I hand over to you and can you explain what is FF4EuroHPC and introduce the speakers, please? So I will hand over to you to present. Okay. Now you should be able to share your slides.
Yeah, thank you very much, Pascal. So I will just put it into the presentation mode, and now we should see the screen.
That's fine now.
Yeah.
Thank you.
So good morning. Thank you very much for joining us. My name is Tina Martz, and I'm a FF4EuroHPC communication lead. And my task today is briefly present you the project, and then we will hear more about the experiments that are performed within this project. So FF4EuroHPC is actually all about connecting business with cutting-edge technologies and then encouraging the innovation potential of European industry. FF4EuroHPC is H2020 research project and is founded by the EuroHPC GU. It's coordinated by the HLRS from Germany, and we have 5 other partners supporting the project. This is Artur from Slovenia, SESGA from Spain, Cineca from Italy, Scapos from Germany, and TerraTech from France. So we are somehow contributing to 4 main objectives, which are increasing the innovation potential of industry, in particular for small and medium enterprises, by using supercomputing infrastructures, artificial intelligence, high-performance data analytics, machine learning, and some other advanced technologies, which actually help SMEs rising their innovation potential and innovation for their business. Then our partners are connecting SMEs with the national competence centers, which were established in the last year, where the end users actually can find experts and access to the state-of-the-art technologies. We are exchanging and promoting good practices, or we are call them success stories, and application experiences, which we are used to inspire the community for fostering the further innovation. And lastly, we are providing an effective mechanism to the SMEs, particularly, where they can exploit new business opportunities through the experiments they are working on. Through the project, there were 2 open calls offered, which were targeting the highest quality experiments and were involving innovative SMEs, actually from the European countries. We received a lot of great proposals, but finally we selected through the evaluation process and also funded 42 experiments, which are including 132 partners from 22 European EuroHPC GEO member states. So all the countries which are colored in this intensive blue color on the map are actually part of the FF4EuroHPC experiments. We are really proud of that because it's a great success for us and for the innovation potential for the Europe. And actually 62% of those are small and medium-sized enterprises which we were focusing on. The experiments that are running through the FF4EuroHPC projects are actually addressing business challenges from really various application domains and various sectors. But mainly we are focusing on manufacturing, so 57% of experiment cases are dedicated to the manufacturing sector. So as soon as experiments are closed, they become a success story, and the success story is highlighting the benefits that participating partners, this is not only SME as an end user, but also HPC providers, ISVs, so software vendors, different domain experts, are gaining the benefits, and this is the real results and outputs we are communicating to the community with the focus on industry. So I'm inviting you at the moment to visit the project website. The link is here, and also in the documents which are attached to your panels. And you can find and search for different experiments we are now executing. And at the end, I would like to invite you to get inspired by success stories, HPC-related events, and HPC-related content on our social media, and of course, through the newsletter. And that is basically all for this really short introduction. And now I would just like to proceed with our first presentation. So the presentation will be held by Emanuele Della Volpe, so aerospace engineer at the Federico University of Naples and aerospace designer at the Aerospace District of Campano. Emanuele has been carrying on research and development course demonstrating the feasibility of an automatic system for the protection of the sea from floating solid waste, which is called Litter Hunter. And we are really proud that Marine Litter Hunter is actually FF4EuroHPC experiment. So Emmanuel, if you are ready, I would like to kindly ask you to start your presentation, and so let's do it.
Okay, I'm ready, and it's a pleasure for me just confirm that you can see my screen.
Perfect.
Okay, perfect. Good morning, I am Emanuele Della Volpe, aerospace engineer and CEO founder of GreenTech Solution. I'm presenting the HPC-based navigation system for Marine Litter Hunter. It's an upgrade of autonomous litter hunter approach through the high-performance computing. GreenTech Solution has developed a unique approach to attack the marine litter problem through an intelligent system, such as an unmanned air and weather vehicles that autonomously identify and collect the floating plastic waste in the sea. The experiment consortium is composed by University of Stedi Partenope, which is an Italian public university with a background in science of navigation. BIREX, the Italian Competence Center with a specific focus on big data and the innovation process. And Cineca for the fundamental computational resource available and needed for the process, for the project. GreenTech Solution has automated the collection of marine litter through a real-time identification of floating plastic waste via manned vehicles or drone. But there is a little difference between a remote pilot system, remote pilot vehicle, and autonomous vehicle. The drone, the vehicle is aerial and catamaran drone that can operate without any intervention of the operator. The drone sends through the ground control station the GPS coordinate of the waste to the boat, which reaches and collects the plastic waste. The operation limit that we have is to predict just 3-5 minutes of the waste movement, just in calm condition. This forces the UAV to stay close to the waste, and we need to use the HPC in order to broke the limited ability to predict the future position of the litter hunt, of the littering. And the HPC experiment allows us to overcome this limit through new features like marine litter recognition, marine litter path prediction, and marine litter recovery strategy optimization. The training for this feature it's not possible under conventional computational resource, but it's possible thanks to Cineca and high performance computing. About the competitor, GreenTech Solution has not found a lot of direct competitors, and is now the only European company that uses the collaborative unmanned vehicle to carry out the cleaning operation in sea in a sustainable way. So just with the solar panel energy and so on. We developed a proprietary solution able to collect marine litter in automatic, more efficiently and cleaning way, reducing the 60% the cost of labor respect to indirect competitors. So HPC will generate direct benefit for GreenTech Solutions, such as the release, the possibility to release a proprietary automation navigation software running in cloud. The accuracy resulting from the computational task that we run in Cineca HPC. A new APR that we develop and we build thanks to this experiment, and a new digital platform for marine litter monitoring that it's now public and you can check it. We are expecting for us a series of results such as identify and classify marine litter in terms of dimension and materials, to have a more accurate prediction of possible trajectory of classified waste over longer time and over a wider area. Then we will have a real-time tool for navigation, optimization, and mission planning that reduce the monitoring of operation energy, time, and cost. Last, we reach 2,000 kilometers of European coastal line, Greece, Spain, and Norway in the next 5-6 years. About the source of data and general the training pipeline that we build thanks to Cineca, we can say that this flow chart summarizes the experiment. In fact, we can see the data acquisition from the drone that is useful in order to have a database for Marine-Litter recognition and a database for Marine-Litter path prediction. In the same time, we have data acquisition from buoy in order to validate the oceanographic model, and we have the training for Marine-Litter path prediction that determine a prediction path useful for the last step of the calculation pipeline that allow us to identify the better recovery strategy in order to minimize the cost and the time for the environmental protection operation. Here there is a short video that show one of the most important steps of the experimentation, where we divide two kinds of bottle, plastic bottle, in terms of buoyancy level. As you can see, for example, the red bottle is quite full, and the white bottle is quite full, and the red is quite empty. And in the 5-10 minutes, the wind force and the sea force separate these two groups of bottles and allow us to determine the path, the movement characteristic depending on the kind of the object and the buoyancy level. Obviously, of the object are recovered for the experimentation. Then we can go about some results. Oh, okay, some results about the Marine-Litter image that allow us to identify a lot of class of Marine-Litter. In fact, for example, for task 1, we use 10,000 of image acquired. 10,000 of image in order to have a high accuracy of waste recognition. For the Marine-Litter path prediction, we have a lot of path, quite 60 million of Marine-Litter path of waste resulting on the oceanographic simulation. And then for laser drift, we have 5 days of acquisition of 4 laser drift, which is a particular buoy that register the coordinate information in 1 complete day. Other information about the training, all of the objects of the image are labeled using a dedicated software, and we can see here that we reach the an high accuracy, quite 90%, in order to identify mask, polystyrene bottles, and other a lot of kind of waste in hard plastic type. About the simulation, here there is an overview on how simulation is performed in the Gulf of Naples, and this simulation generates a lot of passive tracer, so a lot of path that we can use for the training. Okay, this is the training for the path prediction. In fact, here we can see how work the algorithm in terms of monitoring data acquired before the operation and prediction of the path prediction, and we can say that here there is a good accuracy of the path prediction, considering that we have a prediction for more than 1 hour. Okay, the last training is for the optimization strategy. In fact, we use a multi-objective genetic algorithm that is capable to minimizing the distance covered and the time spent by the unmanned surface vehicle to retrieve the marine litter. This navigation is defined starting from the navigation regulation and the vehicle performance limitation, like cruise speed, max speed, battery life, endurance, and so on. So for the business impact and risk analysis, we go in deep from the sustainability assessment and in the advanced business plan. For the this aspect, we identify that the stakeholders are really interested of this solution, and we generate a lot of link from the institution and other subject for the environmental monitoring action. For example, in Italy, we start an interaction and a synergy with an area, protected marine area, and other subject that work for the environmental sustainability. But from the business plan point of view, we want to scale up in a wide country. So we plan to generate 25 new boat and drone in the next 3 years. So we reach a European client like Greece, Spain, and Norway. We use a lot of budget for the marketing and general promotion of the solution that need to be that we want to propose for the other European country, and for the business plan point of view, we produce 50% of potential turnover and less 14% of maintenance cost. The last information is about the general challenge. Here we can say that we want to use a new oceanographic model that can solve a scale problem. In fact, we want to create a right logic for mixing the large scale and small scale. We want to increase the number of the object that the manned surface vehicle that can recover, and we want to obtain local meteorological data from drone. This allows us to improve the data set for the path prediction, and we want to create we want to characterize a script that allow us to size and the object detected from the image. And we want to use a neural network to identify a greater and greater number of object class, just not only the plastic, but a lot of kind of waste. And we want to optimize the recovery strategy of the catamaran depending on the coastal line profile and meteorological and also oceanographic data. Thank you for the attention.
So, Emanuele, thank you very much for this detailed presentation. So I would again encourage all attendees to put some questions for Emanuele in the chat, and we will try to answer them as soon as we close our second presentation, which is actually, I would say, also aligned to the drones and to gaining some really nice environmental also and social impacts, not only business impacts. So our next speaker is Jose Luis Munoz Gamara, is Azulogic's technical director, who is developing decision support systems based on machine learning techniques. And he will now present also one of the FF4EuroHPC experiments, which is titled HERCULES, and develops specific weather-focused models for drones. So, Jose, if you are ready, then you can start with the presentation.
Yeah, I think that you can already see my screen, right?
Yes.
Yes.
Perfect.
Okay. Perfect. Well, okay, that's it. Okay, so thank you very much for this nice introduction. First of all, I would like to thank you, Tina and Pascal. You know, the offer of presenting HERCULES project in this nice webinar, and for sure the rest of the team. So, okay, HERCULES is the acronym of High Performance Computing for High Value Weather Forecast. I am officially the coordinator of the project, and I'm gonna present you this solution. I have divided my content in these points in order to make everything clear. So I will start with the problem and the solution that we are proposing. In order to build that solution, we are going to need different background, different skills. So we have built up at the consortium that I will show you in some slides. And why it's so important for us, high performance computing, that we are obtaining thanks to FF4 framework for sure. Then we will go for the main achievements, challenges, and next steps. Okay, so let's start with the problem, right? So nowadays, general aviation relied on local weather forecasts provided by national agencies in order to, ensure the safety, and even they have some economic impact for sure in the mission. The weather forecast that they are going to have, for example, wind value component for sure is going to impact the fuel consumption, right? So we are relying on these national agencies that they are providing, well, actual weather forecast or current weather forecast, like we can see here in the left side. They are providing information about 7 minutes ago the weather that we had, and they are providing us at the same time some forecasts. In this case, it was provided like 3 hours ago. And it has a timeline of six hours, right? For sure, we have air traffic controllers supporting the operation if there is any change, right? But the question that we want to answer and we raise is how are we going to solve this problem, this weather information problem, where we will have this kind of new aircraft that we are all seeing, right? At the news, these drones and even future air taxis, right? How are we going to solve this problem? For sure, we are going to have some main differences with common aviation, let's say, right? So origin and destination are not fixed, so we cannot rely on expensive ground infrastructure. We are not going to have air traffic controllers. We need a higher spatial resolution, horizontally and vertically. Weather forecasts need to be updated more frequently. Well, every time that I have to talk about urban air mobility, air taxis and drones, so always somebody say, come on, Jose, you are talking about science fiction, right? Well, Emmanuel has proved that it's not science fiction, but I have to say that, well, at some point you are maybe a little bit right, because, you know, for the first time we saw aircraft flying in urban skies in this Fleetsland film in 1927. But as you have already seen in Emmanuel's talk, it's becoming a reality, and I'm going to give you some numbers too, right? So it's already a European strategic. Just in 2020, we have a dedicated budget inside H2020 framework of 35 million. It's already a hot research topic. For example, in the World ATM seminar, one of the biggest conference in air traffic management, 25 of the work presented were focused on unmanned aerial vehicles, on drones. And the European Commission has some quite nice forecast, let's say, or optimistic forecast, saying that in 2015 we're going to have 150,000 people employed in this sector, generating 15 billion per annum. So, okay, so what is the solution that we are proposing? Okay, our proposition has 3 different building blocks, right? The first one is development of a sensorized drone for atmospheric characterization. Then we are going to develop some weather forecast model for low altitude forecast with high spatial resolution. And then we are going to develop some services to provide weather services, right? So in this short video, you can see how we have our drone is sensorized. So we are characterizing atmospheric conditions like visibility, temperature, humidity, wind. And we are broadcasting this information to top control tower in an airport and high performance computing center in order to, run our models. Okay, so our consortium consists of ASLogic. I am the CTO of ASLogic. We develop decision support system for aeronautics, and in this last year we have been working a lot in unmanned vehicles services. We need some help, so that's why we have our friends, our colleagues from the University of León providing advanced methodological models, and for sure we need to run our advanced methodological models, right? So we have in the consortium our colleagues from TESGA that is providing the knowledge and the capabilities to run this model in a supercomputer in the high performance computing center that they have in Spain. So we were not expert in high performance computer, not even in weather forecast. So I'm going to try to highlight why FF4 has made a difference for us, providing us these high performance computing capabilities. So we are going to provide this weather forecast report that at the end they are going to rely in weather research and forecast models. They are numerical weather prediction models, and thanks to them we can do things like do a idealized simulation of a thunderstorm or do some experimental real-time forecast. Well, in a really simplified way. I don't want my friends from University of León get mad with me, but I'm gonna try to highlight to get you some insight of why this high performance computing is so important for us. So when we are running this model, we are trying to solve this equation, differential equation and regular equation, right? And well, I used to be I'm a former physics student, so every time that I have to solve all these complex differential equation, at the end I knew that I need to do it using some numerical method, right? And at the end, numerical method means time, means a nice computer, so computational power, and have the expertise to play with the right parameters in order to be able to solve the question, right? So, and for sure, these solutions are gonna be just valid in a given air volume. Well, and we are gonna apply some contour condition in these air volumes, and at the end, we are gonna divide the region in which we want to have this weather forecast in these small cells, and the resolution of this small cell at the end is going to impact in the computational power that we are going to need. So, for example, for the region in Galicia, is a region in the north of Spain. We have an area of 30,000 kilometers square, and we are going to provide a resolution of 3 kilometers horizontal at different altitudes. So we are going to have 10 meter, 20, 50, 100 meter, and 125 meter. So imagine during the the process of developing the models, for sure at the beginning we are going to need to tune all these parameters that I have previously said. So in this specific product in HERCULES, we are going to have 4 different weather work parameterization, right? And in each of these parameterization, we have 23 variables to be tuned. So the advantage of using high-performance computing resources is that we are able to shorten the development time, maybe from months using our, well, I would not say a regular computer, I would say a good computer in our own facilities to days. And then we will have to run these parameterization models, this work model, right? And as I have previously highlighted, we are going to try to forecast the weather in a region of 30,000 kilometers square with a slow resolution, right? So at the end, using high-performance computing center, we are reducing the execution time from tens of hours, let's say, to minutes. At the end, it will depend on the computational power that we are using, right? So at that point, while we were doing the HERCULES project, we were out of question raised. Like, is possible to solve a problem with self-resolution in a timely manner? How quickly do I need a solution? What is horizontal and vertical resolution do I need for my purpose? How many cores do I need? How large is the data set that we need to load? How much memory do I need? So a lot of problems. So we need some help. Thanks to FF4, we have this guy involved, and they help us to solve all this question. So just to give you some insight, during the first tuning of our parameters, Tesca provide us with 491 core hour. So it means that we can do this tuning of the parameters quite easily without running a simulation and coming back to our computer in 3 hours, right? So it was quite fast to check if everything was going right or not. And then we were running now that we have fixed the parameter, we are running our model 4 times per day. That's something that you can change for sure. The running time of our model is 1 hour and 30 minutes, because we are using now 12 core hour. For sure, this is quite important for SMEs like us, in which you need to choose your running time, because at the end, it's fixing the resources that you need to hire in the high-performance computing center. Well, it's not a problem for us now that we are in FF4 framework, but it's something that we need to study carefully in the future, right? And we were generating like 10 gigas per execution. So we are reducing the execution time as I have already said. Okay, so now let's go for the drone that we have using. We call it Metro drone. So as you can see here, well, we have some temperature and dew point, wind sensor. We need to carefully design the position of the wind sensor in order to avoid the interferences of the rotor in the measurement that we were doing. And here you can see the Metro drone. We're flying in an airport, and the nice thing that we have here is that, okay, so we have our drone characterized in atmospheric condition, but at the same time we can validate that our models and the measurement that we are doing are good, as we have of this nice ground weather station that they are using in this specific airport, so we can double check if our measurements are right or not. So what we found, okay, so we have better wind characterization at low altitude than traditional ground infrastructure, because with ground infrastructure you have the anemometer that the measurement are quite good from ground to 10 meters. Then you have sonar in order to measure wind, but the measurement is good from, let's say, 50 meters to 125 meters. So we have this interval of altitude in which, you know, we don't have the better equipment to measure atmospheric condition at that point. And, you know, drones are going to be flying in this altitude. So it's quite important for us. So with the drone, the problem is solved. We can you know, fly at the position that we want. So thanks to HERCULES and FF4, now we have Galicia fully characterized. We have done some data harvesting campaigns in 4 different locations with more than 120 flights, where we have the resolution that I have already said, and the accuracy, for example, of the wind is 1 meter. We have an error, right, of 1 meter a second in 80% of the territory, so it's quite nice. So here you can see some videos of the solution that we have developed. In this interface, you can see how the operator is fixing the trajectory that he or she is gonna fly, and what time they are gonna be flying, and they are giving some specification of the drones that they will be using. So once that you send your mission, you are gonna have this representation in which I am showing wind condition, well, in this case, temperature at different altitudes and the different points that you are going to fly and at different times. Well, we have a rich database with different drones, UAVs, models, and we are giving them here the risk of the operation. So in green is okay, no problem. Yellow is caution, and red for sure is high risk operation. But you know, they are deciding at the end of the day. We are just giving them the information. And for sure, one super important parameter that they need to have is wind direction and wind value, right? So we are doing that. So we are doing this representation in order to get to, you know, to ensure the safety of the operation that they will be performed, right? Okay, so for SME like us, and you know, our resources are limited. We are a startup at the end of the day, so it's quite important that well, we have had the end user involved from the beginning of the project. So our product has been developed together with them. So we are sure that we are aligned with their needs. And well, challenges that we have found and we will be solving in the coming month, let's say, we see that the accuracy of our models, they are not so good when we have some temperature inversion, something that you already know, where warm air go up, but if we have an intermediate layer here, we can have some reflection. So careful with that. Well, careful when we are developing, when we are using our model, is something that we are working on. And then sometimes we are flying in remote areas, right? So the communication coverage is not so good. So well, we are trying to find alternative methods in order to send well, the readout of our sensor. We are checking now LoRa, that is IoT, so communication protocol. Next steps. Okay, so we think that our solution is quite useful too for, you know, regular aircraft, commercial aviation, because, you know, when they are doing the approach, if they have some wind shear, so the wind component change the direction, they can have some lift problems, and at the end it can damage the aircraft and for sure the safety of the mission. So we are starting to study how can we integrate our solution in bigger airports, right? For sure, we have some certification issues that they're gonna be a headache, let's say, but well, for sure, they need to be carefully studied. And then the last point is, okay, so our model are meso, so it means that the horizontal resolution is gonna be around 1 kilometer, right? So in the future, when we will be flying inside cities, we are gonna need to reduce that dimension to 100 meters. So we need to start using new techniques, right? So we plan to use CFD, so computational fluid dynamics and artificial intelligence algorithms, in order to be able to reduce the resolution of our models. That was all from my side. I hope that everything was clear. I will be happy to answer any question. And that's all. Thank you very much for your attention.
So thank you very much, Jose. It was a nice and really clear presentation. And now we are stepping in the last part of this webinar. This is Q&A part. So we already invited you to put some questions for Jose and Manuel in the chat. So we have some. So I would like to start with Emanuele. So the first question goes, is the USV avionics and HPC electronics in general a safety critical avionics system? And are they somehow red hat?
In general, the system attempt the general safety regulation. So, for the safety point of view, we have a sensorized infrastructure that allow us to identify the presence of human at the sea, or the presence of other boats. This information create a dynamical geofence for the catamaran that not make possible to create a collision. This is the first safety approach, but our work plan aims to implement in the navigation algorithm all the regulation for the navigation at sea. In fact, our system is able to create a navigation path matching with the COLREG 17.2, which is international regulation for collision at sea, and SOLAS, which is the safety of life at sea, another important regulation for the safety region of autonomous navigation at sea. For any other detail, I can answer.
Yeah, maybe you can also send some detailed question or some, if you need some further explanations, to the email directly to Emanuele. It's already on the presentation he provided, so you can find it in the handouts. So the next question goes, what are the possibilities you see to reduce your models even more to achieve shorter execution times during your daily runs?
For us?
Yeah, I guess it's a question for Emmanuel.
Okay, can you repeat the question? Sorry,
So, yeah, what are the possibilities you see to reduce your models even more to achieve shorter execution times during your daily runs?
I don't understand very well the question, and probably I can answer with I can give my email in order to go in deep about this question.
Okay, so
I think it was Mikey's question. Mikey, maybe you can explain what you meant.
Yeah, bonjour.
Yes.
Sorry, it was addressed to Jose.
Oh, sorry. Yeah,
it's me. I messed up with the tool. I'm sorry for this. But so we can come back to this later if it makes sense for Jose later.
Okay. So maybe Jose, we are already here, so maybe you can answer the question if you like.
Yeah. So at the end, and I say that during the presentation, you need to carefully design or choose the computational power that you are gonna be using, and at the end of the day is the execution time that you are gonna have, because it will be related with the fixed cost that you will have using HPC resources, right? So at that point of the project, we are running the models at the specific times of the day in which we know that we will have some operators using the facilities. So we don't have this need or this higher requirement in terms of having our model output like super fast, right? So, but the point is, okay, you want to reduce the execution time, you need higher high performance computing capabilities. For our specific software, our specific software, it is a term of course that we are using. We are not using any GPU, it's just core. So we need to increase the number of core per hour that we are using, and that will reduce the execution time. But at the end, not inside FF4 framework, but careful that at the end you are reducing your I'm not gonna say that the money that you are earning, right? Because you are spending that money in another stuff. So as a startup and as SME, it's something that you need to careful. You need to think it through. Let's say that.
Mm-hmm. So hope that we get the answer we were looking for. So the next questions goes for Emanuele, and Lucas is asking, how much HPC resources did you need to train your models?
Less or more to 250,000 hours. So it's a lot of hours. So we use a Marconi 100 clusters that allow us to reach this level of computational resource need with quite a more 8,000 hours.
Okay. And then we have a question for both of you. So maybe I would ask Emanuele to answer first, then we proceed with you, Jose. And the question goes, how did you find your project partners for the FF4EuroHPC project? So for your experiment, how did you proceed with searching the right partners to execute your work in the experiment?
But probably we start about the stakeholder of the specific topic. We need the Partenopea University, for example, in order to have an oceanographic model simulator that allow us to training the neural network, for example. In the same time, we need Cineca for the computational resource, and the last Virex, in order to pass from a research point of view, from a business development point of view. That is the real core of this experimentation.
Mm-hmm.
Well, for our specific case, we knew University of León, their meteorological models, weather forecast model. Well, in general aviation, let's say in commercial aviation, we knew that they were working on that. And thanks to FF4, we thought, okay, we need to contact one of these high performance computing centers that we have in Spain. At the end, you don't have so much, right? So many of them. So, well, it was quite easy for us to contact them. And they were super nice and they were super happy to help us. So I encourage Luca. I thought it was the name of the Luca. So I encourage Luca to try to contact them, because sometimes they have some funding, they have some good opportunities, some advantages for small companies. So it's worth it to to send an email, and I'm sure that you will have a nice answer.
Yeah, so it's somehow I'm trying just summing up. So you somehow worked with the partners that you already know somehow, or were then help you find out or reach out the right partner through the NCC. Maybe at this point, it's a good way to find appropriate or the nearest located NCC in your country. Through the EuroCC project website, you can find the list of all 33 national competence centers, and there are contacts which where people can find the appropriate information, the appropriate person who can help them for their further maybe business development research activities. So I think that we came to the end of the Q&A.
I had the last question. I had the last question to Emanuele.
Sure. Sure.
It's curiosity really, but I mean, they started their operations in, I mean, their tests in the Gulf of Naples. But I saw you had a business plan, and I mean, the business potential is obvious. So, what are your next targets? I mean, geographically speaking.
Our target is to reach the near European countries, so like Spain, France, and we hope that this possibility to make in touch with other company in the European, like Jose, with the HERCULES project, it's a good example on how we can interact with other company in order to generate a scale up, a faster scale up, and we hope so to reach the Spain and France and Greece coastal line the next 3 years.
Good, thank you.
Thank you too.
Okay. So I guess we came to the end of this webinar. I would like to thank you all to being here with us, especially also to our speakers who presented their, I would say, hard work, because it's not an easy task to innovate, to find appropriate technologies and get the results you are expecting. So the experiments will be closed really soon, some in the next month. And then we are expecting success stories where the highlights will be provided on the project website. So at this point, Pascal, if you have some final goodbye wishes, otherwise, thank you for my part.
Yeah, no, I just wanted to thank you all. Thank you, Tina, for putting us in touch with Jose and Emanuele. This was really a very interesting webinar. It's fascinating to see very concrete use cases for HPC, because sometimes it remains very high level, and here it's really nice to see what it can be used for. So yeah, thank you to the three of you, and enjoy the summer break. I'm sure you all are going to have a summer break. So ETP4HPC is also having a summer break, at least for our webinars. So we'll see you in September. Our next webinar is on the 16th of September, and it's about another project. It's about the EU Master for HPC. So I hope to talk to you all in September. Bye-bye.
Thank you. Bye.
Thank you very much.
Thank
Bye-bye.
you. Thank you. Bye-bye.